First of all, thank you everybody for joining us in today's webinar. If you've attended some of our previous webinars, we've gone over the discussion of digital mission engineering. The vision of digital mission engineering is to connect all of the engineering and system models to the mission model that is going to be rooted in a multi-domain physics environment. Ideally, these models would be pulled as early as possible in the process and persist through the life cycle. And so we've discussed the concept of the digital mission modeling, and so I just want to touch on this digital thread. So it just illustrates, so you'll see in this slide, in the digital thread, you have your initial mission model design incorporated into a multi-domain physics environment systems model. And then the whole idea of having this continuous digital thread is that you can make updates and changes to it and know that the setups and the systems you have created will be updated and implemented all through the entire life cycle of this digital thread. So each of these are going to be tied together so that when you change some individual part of the model, it will pull the rest of the model as well. And it really will help you achieve a faster analysis and a more sustainable mission design. So in order to achieve this vision, it really requires an ecosystem of commercial tools that all integrate together from the beginning. So in the middle over here, we highlight STK, and as we'll go through this lesson today, we'll also be using Python tools that can integrate together and allow you to develop custom tools that allow you to look at each different phase and life cycle of your mission. Using these tools coherently all together makes it much easier to identify critical issues early in your process and help you speed through your analysis itself. So having an organization-wide ecosystem of these commercial tools allows you to quickly transition from program to program and not have to continually rebuild custom tools at a time. And so this brings us to the topic of STK itself. So AGI has been in the mission modeling world for, as of now, 31 years, developing this mission modeling framework. We strive to have our open data-driven models where you can push your custom models into this physics-based environment to see how they all interact. It allows you to scale and collaborate your product. You know that you are in the same reference frames. You know how to add scalability and flexibility to your model. And not only that, but within STK, we have over 40,000 mission effective metrics. So once you push your models in there, whether they be your sensor models, communication models, threat models, and so on, you can push those in and then pull out any relevant data that is important to your mission. And so STK is very broad and it's very deep, and it has an open API that can be used to easily automate, customize, and integrate with any other standard data tools, programming languages, and data formats. And we'll actually be leveraging that API in today's virtual training when we drive STK with our Python Jupyter Notebooks script. So in this class, we will be focusing in on the STK Python integration portion of it. But I do just want to touch on some of the other resources that you have. So on our support page, we have a ton of tutorials that you can utilize. We'll be specifically looking at some of the Python code snippets, but we also have code snippets from other languages. You can download different files and always know that you have people on your side to support you, whether you're in a closed environment, somewhere on site, or just need to call someone else or send them an email. We have resources available to you. And just to wrap this up a little bit more, we will specifically be talking about the STK integration aspect of it. That's underneath the STK systems bundle. But you can utilize your integration with any of these other tools if you wanted to automate, customize, or visualize any aspects of your mission. So the STK integration license gives you a lot of flexibility for what you want to do in your mission. Right. And then I also want to talk to you guys about the actual integration aspect of this as well. So let me show that. Perfect. So throughout this virtual training class, I'm going to be talking about STK integration with Python specifically. So I just want to give you guys some background as to maybe why you would want to use an integration tool or have some scripts. And truthfully, it gives you a lot of flexibility. It gives you a lot of dynamic control for what you want to do in your mission. So you can integrate STK with MATLAB, Python, Excel, any other tool that you want. We specifically have these as written out tutorials. They basically go over the same scenarios, but you can leverage other tools like C#, Java, and so on. So STK gives you your environment, your physics-based environment to model your vehicle dynamics, sensors, just your different visualizations and physical environments. But these other tools, like your Python, your Java, your Excel, and so on, allow you to do additional numerical analysis, additional plotting for your data, and just give you a programming environment to use. So you can use it for analysis, and if you wanted to use it for analysis only, that's totally fine too, but you can also use it for analysis and visualization. So you can take data from, say, your MATLAB script file, push it into STK, visualize it from there, and then post-process it with additional data. Alternatively, you could have something modeled in STK and then pull it into your Python, whatever it is you're working on, or your Excel code, and then just go back and forth with moving your data and giving it some life, just giving it a new way to understand it and customize it. All right. So you can mutually extend and leverage each application's analytical capabilities. Like I said, with STK, you have over 40,000 metrics of mission effectiveness that you can use. And then, of course, using these other tools to leverage their numerical analysis, push data, customize stuff, and then push it into your STK model, and then get additional information from there. So it lets you get a cohesive environment and gives you additional flexibility for what you want to do. The advantages of this, of integrating STK with other tools, is you, one, first get to automate your procedures. So that allows you to access capabilities of those tools without having to switch between your different application sessions. So for example, you could use MATLAB to modify a scenario for a trade study, like we did trade studies last week, but then you can also use STK to evaluate the mission or any other relevant conditions. So maybe you're doing a communications analysis, and so you want to do some signal to noise calculations. So you can automate a procedure with MATLAB, but then also leverage the mission effectiveness components from STK and get an understanding of your data. Automation also allows you to do repeat analysis. If you know you're going to be updating mission and doing the same type of analysis study over and over again, automating it is a great way to sort of speed up your whole workflow. Next, you could also extend or augment the types of analysis that you can perform with just one of these tools. So, for example, you could use the STK satellite propagators in your study, but you might have a custom sensor, and so you would create that, define that, and then push it into the STK model. And then, if you wanted to post-process it, maybe the type of component you wanted to create is something a little bit different than the 40,000 metrics, but then you can post-process it in MATLAB or Python or whatever else with the STK-generated data. And finally, visualization. So STK has the 2D and 3D graphics visualizations to view any georeferenced or geometric data from your different applications. So you can take large sets of data from your Python scripts, from your MATLAB, from your whatever, and then push it into STK to visualize it, view it, and see what is going on. And then, of course, you can pull it back out to do any additional plotting that you might want to do. Okay. So not too much to touch on this, but I do also want to mention that there are a couple ways you can connect your tools and capabilities together. One is using the Connect library, and then the other is using the STK object model. Neither one is necessarily faster or slower than the other. It's really just up to you as to how you would want to utilize these libraries or use them. So like the STK, the Connect library communicates with STK and the 3D graphics, so you can visualize events in real time. So for instance, you could use Connect to field real-time telemetry data from like a launch or an early orbit of a mission, and then the data could be viewed in the 2D or 3D graphics to visualize the entire mission. And then the STK object model, it's a collection of common libraries containing your types, interfaces, events, and classes, just representing the various aspects of the STK application structure, which does make it a lot easier to build custom solutions using STK and the STK engine. And then the various components provide developers with the capability to control objects, just manage the lifetime of the STK objects, access to data provider tools, do your access computations, your coverage computations, and then respond to the events that you are generating in STK. Let's see, the STK object model is available to use with STK as well as the custom built STK engine. Let me think what else I want to mention. And then, Connect will natively understand and command any sort of action that you could do in the GUI itself. But you can use one or the other. You can leverage both in whatever code or whatever script you're writing up or anything that you're trying to create. But these are your core libraries that you can utilize as you're integrating STK with your other tools. There is different naming conventions, so we'll see this briefly as we go through and look at the script. So I just want to talk a little bit about this. So your classes are going to be prefixed with the term AG, which stands for AG, like AGI. Interfaces are prefixed with IAG. Enumerations are prefixed with AGE. So I just wanted to pull that out there. So as you look at some of the code snippets, the code samples, or even the script itself, you just understand where that terminology and the naming is coming from. All right. So you have your STK object model, you have the STK object model, the Astrator object model, and so on. So there's a lot of ways you can incorporate the STK object model and leverage your different capabilities in STK. All right, just going into, I guess, a little bit more about the way things are structured or the terminology is used in STK. The IAG STK object, it exposes the methods and the properties. The AG STK object root provides the methods and properties to load scenarios, create new ones, and access the object model unit preferences. And the IAG STK object collection will hold the children objects of a particular object. But honestly, we have a lot more information about this on our website that you can definitely review. I'm going to take you guys to the website for just a little bit, and what I will be showing you guys is some of our code snippets. We have our code snippets in 4 different examples. These are not the only languages that you can use with STK, but these are ones that people commonly will commonly use, and so we provide these code snippets so that you don't necessarily have to begin coding from scratch. You can utilize these in your script itself. And then just when it's going to be relevant. But you will also find other languages and code samples referenced on the help page. All right, and then finally, in our data, in our actual script, we will also be pulling out the some of those metrics of mission effectiveness from our data sets. And so when you are generating data from STK, the important thing to note is to know what data provider for the object you are analyzing. And so we have this information on our help page, but even in STK, you can actually look from the report and graph manager and select the data providers that are going to be relevant to you. Yeah, and so going through it through the STK way will actually give you an idea of how you will need to navigate and point to your different data providers. And we'll also see this when we are generating our script for one of our examples. But I do also just want to mention that we do have this information on our website. So let me take you to that website now. So if you guys have a moment, I do want everybody to open up a web browser. If you're doing this through Frame, that's totally fine. You can do that too. My Frame instance just timed out, so I'm going to let that resume and open up. If you guys haven't been here, I definitely recommend that everybody open up a instance of Chrome or the web browser and go to help.egi.com. Here you can access the STK help, which is your general help. But what I wanted to take us to is this STK programming interface help. And I want to take you guys to this tutorials, code samples, code snippets, and online resources. So from here, we have different tutorials that you can utilize. So using MATLAB for STK automation, using object model. Notice that we're referencing C#, Java, MATLAB, and Python. If you wanted to take a look at the coverage tutorial or build your own plugin, you can utilize these and use this sort of as a guide for building your own scenarios, building your own missions, and designing, automating, and visualizing stuff. What I also want to take us down to is this code snippet section. I find this section to be probably like my favorite, and this is my personal bias. But I like it because it gives me quick examples of common scripts that I might need for my actual code. So we are going to be focused in on the Python aspect of this. I'm going to just open up the Python code snippet. And then up at the top, it gives me a lot of common steps and situations you might run into when you are designing your mission. So starting off from the beginning, connecting to a new instance of STK or starting a new one, generating your access, and so on. So I do recommend that if you want to keep this open, if you also want to have the script open, definitely do that. But what I'm going to have us do is I'm going to have us actually get started on the Python aspect of this lesson and actually dive into the script in the lesson itself. So what we have done is we have actually placed a Jupyter Notebook on the instance of Frame so that users on Frame can access it. Alternatively, if you have STK and Python on your own machine, you can just download the file through the link and then open it through your Jupyter Notebook. So in this training class, I'm going to close up these guys up here. In this training class, we will be essentially driving or running STK through a script. So what I'm going to actually have us do is I'm going to have us close the STK window. If you opened up STK on your own machine, go ahead and close it down. And instead, I'm going to have everybody launch their Jupyter Notebook. If you are doing this on your own machine, what you can do on your own machine is just like launch the Jupyter Notebook. And let me relaunch my STK Cloud session. But if you are using this on your own machine, then you can open up your Jupyter Notebook. It will open up in the browser for you, and you can just navigate to wherever your files are. And so you can open up your Jupyter Notebook this way. Alternatively, if you, so let me just open up my terminal. Alternatively, if you wanted to open up Jupyter Lab, just another way to view your scenario, you could do that as well. That'll also open up a new tab in your instance. And then you can just navigate to wherever your file is, but then you'll also see your script itself here. So let me just take you guys through opening it up through Jupyter Lab and the Jupyter Notebook just another time. On your own desktops, either you can just launch Jupyter Notebook, or if you type in terminal, it'll open up your command prompt, and then you can do what I did, which is just type in and launch the Jupyter Lab. And then that will open up the instance for you. Keep this window open if you wanted to use it on your own machine. If you close it, that will close out your session in either the notebook or the lab. So you can use either the Jupyter Lab view or the Jupyter Notebook view. The script will work just fine either way. It's really just a preference if you wanted to view it as your in this format versus wanted to view it as a notebook like this. So for those of you guys on Frame, yeah, just use a little gear icon and launch the Jupyter Notebook. Keep in mind that we will be launching this from we'll be launching STK from scratch. So if you do have an instance of STK open, you can go ahead and close that down, and that's because this will actually go through and launch a new instance of STK. So I just want to go over what this script says and what it looks like, just to give you guys an idea. So going from the top, you'll notice that this lesson is broken out into different sections. Spoiler alert, okay. And then if you wanted to compare this to the lesson itself, the PDF is included in this webinar, you can open that up. But I just want to give you guys an overview for what to expect. The very first section of this script is going to be about creating a new instance of STK, setting up the Python workspace. And I was playing around with this, so let me clear stuff up. After we set up our instance, we'll have IntelliSense within our script. So what that will allow us to do is, as we write in different commands, we will be able to leverage the STK interface and then be able to bring over the relevant variables and things we want to know. I should also mention that if you wanted to build this script from scratch, I can walk you guys through that. You can go back to your main directory of files, and you could create a new notebook for Python 3. That's the version I'm using. And so if you did want to build this from scratch, it would just, your window would look like this, and you could go through step by step and just copy the script from the PDF over into your actual notebook and then run it to run each section. All right, so I'll have us run this through this notebook view, but once again, if you wanted to run it in the Jupyter Lab view, totally acceptable, definitely up to you, as it is a preference. All right, so I'm going to go through and just walk us through this step by step, just to give you guys an idea of what each command is doing and how we are setting this up. So we're going to be connecting STK via Python, and that'll also allow us to pull in the IntelliSense capabilities and definitely make it much easier as we create the rest of our script. So all I'm going to do for this section is just run this cell. You'll see that right now it's going through and it's processing, but what it's doing is it's going to be capturing an instance of STK or creating an instance of STK for us, and then also grabbing a handle through this root command down here. Once you run this script, what you'll notice in the bottom of your browser is a little STK window icon. Perfect, that's what we expect to see. And that's all we'll do for this first step. We don't need to run it twice. We're just going to run it once and then go down to the next section. So the next section is about referencing the com types and the libraries we'll want to use. And just as a note, when you are writing your own Python script, once you run these the first time, you can actually copy them and then paste them in the beginning of your scripts going forward. But since this is going to be the first time we're running it, so if you're running this on Frame or your own machine, you'll want to run this later on. But then, of course, once you've run it once, it'll be set up on your machine, and so you can just have it always be at the top of your script. All right, so all I'm going to do is hit run this cell. We'll only need to run it once. And then we can go down to the next section. So we have launched STK through the Python interface. This is this little STK window floating there. what we haven't done is create a new instance of STK. So we're going to be creating a new scenario, giving it a name, running that root command, creating the scenario object, which is going to be root.currentScenario. And so when we write in our script and we are creating our scenario object, we'll just be using the variable scenario for that. And then we will be setting a custom time period for the scenario as well. We'll have it start from this current time of our day and have it be 24 hours long. And then we will also reset or basically start our scenario from this time as well. So all I'm going to do is run the third cell and let that create my new scenario. All right, so now that we have created our instance of STK, if we look back at our STK object, we can see it right here, same as we would see had we just opened STK using the application button on our desktop. But next, what we'll go through is we'll actually fill in the objects that will be relevant to the mission itself. So our mission in this example is going to be some satellite in low Earth orbit, going to have some polar orbit, and we're going to have some ground station, and our whole goal and purpose is to be to quantify the relationship between those two objects. So that will be our ground system and then our satellite. We will actually go through and insert these in one at a time. So I'm going to begin by bringing in my ground object, which will be a target object. The object is going to be an STK target. So if you look at this script line over here, we, in our scenario, are creating a new object, and the STK object type is an eTarget, and we are going to name it ground target. All that will do is actually load in that target into our scenario. So now we're essentially in target 2, essentially pointing to it. And after we point to it, we get to change certain parameters. So for our target object, we will adjust its position and give it some unique latitude, longitude, and altitude. We don't need to incorporate units for this, just due to the way STK is expecting this information to come in. But you can always look at the code snippets to get more information about it. Next, we will bring a satellite into our scenario, the same command format. In our scenario, we are going to be bringing in a new object, and this one is going to be a satellite that we will then call our LeoSat. Right. But the way we will define this is going to be a little bit different. So if you look down in the next section, it says, or the next line, it says root.execute command, and then a whole line of information over here. What we're actually leveraging in this specific line is our connect command. So we will be telling STK what the orbit is of the satellite, but rather than manually entering the orbital parameters one at a time or however we would want it to be, we're just using a connect command. We are going to be setting the state of the object. The object itself is going to be our satellite, using the two-body propagator, the standard classical orbital model, from the beginning of our start time to the end, and then giving it its own unique orbital parameters here. The format of this is just from the connect command, so if you did want to see what that looked like, I can actually take you guys to that right now. If I go back to my help documentation page and then click STK help, on the left, using the little table contents, I can expand integrating with STK and then the connect command library. I actually prefer the alphabetical listing just so that I can see everything there. And if I wanted to see what the set state looked like, I could click the S section. It would take me there, and then I could scroll through till I find set state. And notice that there's a couple different options over here. I remembered from the script that it says something like set state and it was like classical, and that is in fact the script itself that we're using. And what's nice about the connect tool is that you have this like format available to you, so you can see exactly which parameters are needed. They have an explanation for each one, and then also some examples down below. But yeah, so you can leverage and utilize the Connect format and the Connect script for your lesson. I will say that it's definitely up to you as to which format you want to use. One isn't necessarily faster or slower than the other. It's just truly as to how you want to use it and run the script, which that brings me to it. Let's run this section. So all I'm going to do is click Run this cell. And then I'm going to take a look in my scenario. So I do want everyone to quickly pull up their actual scenario open so they can see it. And just notice that you have your ground object, so your ground target, and your LEO set in your scenario. So if you were automating some aspect of your mission, you could have it so that you basically hit a button and insert in the relevant object to your mission, and then see them interact in the scenario itself, visualize it, so maybe it's a custom orbit or there's custom components to it. You can push those models into STK and then visualize them. All right, so our goal in this lesson is to quantify the relationship between our satellite and our ground site. You'll notice that the next section is sort of blank. So what we're going to actually do is we're going to look up the relevant lines of code that we'll need to actually compute access between our two objects. And so the recommendation here is to use the IAG STK object interface. And looks like there's a link that takes us directly to the object model Python code samples. So I'm just going to copy this, open up a new tab, and then just go directly to that help documentation page. I will say that I don't necessarily think that the coding aspect of it or that is going to be as tricky for users. I think the part that people should know and just focus in on is finding the relevant resources and the information that you need. And so that's why I think this code-specific page is very, very useful. So like say, for example, instead of launching a new instance of STK, we instead had our script connect to the open instance. So if you are in Frame and you want to connect to the scenario that just opened up, you can actually take a look at the initialization code that, lets you do that. All right, so let's talk about access. We want to quantify the relationship between our two objects, and so we want to compute access between them. Now, it looks like there's two methods we can use. So we can use the STK object using the object path, or we can use the IAG STK object interface. Why don't we look at both of these just to see their differences and their similarities? What I also want to point out with these code samples is that they're not just simply like copy and paste this into your script. Just some thinking involved right here. Up at the top, it will tell you which objects the script or which objects you already need to find in your scenario in order to use them. So it looks like this is using an IAG a satellite object and then a facility object. So then it is referenced as a satellite and then a facility. And then the very next line is essentially that compute access. Alternatively, if we didn't want to use that and we want to use the object path, we would just need to know how objects were named in their scenario and what their parent, like their object type was. So in this instance, we still need our IAG satellite object, so that is our satellite over here. But instead of just getting access to something called my facility, we will need to navigate to the facility object, and specifically the one named my facility, and then we will compute access. So let's go back to this IAG STK object interface option here. And just as a quick note, we do not have a facility object in our actual script. Our actual script is between our satellite and a target object. It is defined as an IAG STK object. That makes things easy, but it is not a facility. So we can't just simply copy and paste those lines of code. We do need to do some thinking about it and make some changes. So I'm going to just copy this section. And then I'm going to go back to my script and I'm going to paste them in there, but I'm not going to run this section just yet. I'm going to actually do some renaming. So I want a IAG target, and I want to get access to between my two objects, but I don't actually have a facility in here. So instead, I'm going to do target. And if you start writing your term, so if I wrote TAR and use tab, that would give me this little menu that pops up. I do want everyone to take a moment to do that because this is leveraging that intelligence, telling you what variables you have and which ones you can use. And so here I'm going to use my access. I want to compute access between my satellite object and get access to the target object. So that's the change I'm going to make over here. So I want everybody to take a moment to write that in there and then update it. But once they do, then they can go ahead and run this section. Alternatively, if you wanted to run this and then actually put semicolons at the end, that will suppress the output. So right now it says output 0. That's fine. If you actually look in your scenario, you will see those access lines appear in your display. And as long as you didn't get an error message, then everything should have computed just fine. But if you do put the semicolons at the end and you run the script, it'll still do everything you want it to do. It'll just suppress the output message that you might see. All right. And then the next thing is retrieving and viewing the data in Python. If you got an error message down below here, that is likely because there was no access actual command written beforehand. But now that we've written in there, we'll rerun this again to get our data. I happened to test it out beforehand, which is why I basically am like a chef who like bakes the cake and shows you the final result before putting the cake in the oven. All right, so retrieving and viewing your access data in Python. So there are copious amounts of data providers within STK that you can utilize for your mission. And I said that you can just take a look at the help documentation if you wanted to figure out which parameters you wanted to study and understand a little bit more. Alternatively, if you do have your STK scenario open, just so that I'll show you guys a different way, I'm going to open up the properties, or I'm going to open up the reporting graph manager, and I'm essentially going to create a new report and open up its properties, because what I want to show is just the all the data providers that are essentially calculated under the hood in STK that you can then pull out with your script. You'll notice that a lot of these have like subsections, different parameters that might be relevant to your mission, more important, or so on. And so that's how you will go through and you can figure out which data providers you might want to run. So for this example over here, I'm going to be pulling information from my access data and specifically just pulling out the start time and the stop time. I'm not pulling these out because they are super important or significant. I just think that they are easy to understand parameters. But once again, as you start evolving your analysis and doing a larger scale study, you can do fancier things like I said, like pull out that signal to noise data for your communication system, or just different parameters about your launch that you are trying to analyze and post-process. All right, so specifically going to be pulling out the access data. I will also say that a note for using Python for your data and for how you want to pull it out, you will have to create a pointer for, or you will be essentially creating a pointer when you have your like access data providers, and then you will need to query that data to load it in, and most often will be by the format of the data type. That's why I think the code samples are very useful, because they do have this format worked out, and so you can always customize it and make it work for you. But that's why you'll see like access data providers, and then access data providers too, essentially because we are pointing to it and then querying it as well. All right, so I'm going to just go ahead and run this cell. And then I have my information pulled out below in the like right underneath. And if I wanted to post-process this and load it into another tool, obviously this is my serious start time, not merely as significant. But if I had other parameters I wanted to understand a bit more, I could certainly analyze them and look at them more. All right, so finally, the next section is retrieving and viewing the altitude data of our satellite during the access interval. So here is once again when you are querying your different data just to understand what, like where it is and how to find it. So if I actually open up my reporting graph manager again, and I look at, yeah, I do want to be on my satellite object. So for example, if I did want to look at my satellite data, so currently I'm going to be pulling in data from the LLA state. And the unique thing about this is that this is one of those categories where there is a subcategory as well. So we're essentially going to be pointing to two different locations, like first to the LLA state and to the fixed directory, specifically so that we can pull out the altitude or any other information that you might want to see. So those first two lines are just about pointing to the to the LLA state and then the fixed directory. And then, of course, we can pull out any elements or report out on any elements that are going to be relevant to us. So we'll just have like time, latitude, longitude, and altitude. Next is going to be how you want to pull out that actual information. So from my data element, I am going to be, so between my axis start time and stop time, at 60-second intervals, I am going to want to query my different data elements. And then to just pull in the altitude data for one of my elements, I am simply just going to get those values and then print them out in the display below. So I'm going to go ahead and run this cell and then pull out just the satellite altitude information for my satellite during a period of my axis interval. And this, of course, will be, the same type of information that you would have in your STK scenario. But the benefit of this is that if you did want to, actually can generate like an LLA report too. Yeah, so we can pull out my information here as well. But then what's nice is that since I have loaded it in and pulled it into my Jupyter Notebook, into my Python stuff, that if I did want to post-process my data or just to do further analysis for it, I certainly can using the different Python graphing capabilities or post-processing numerical analysis that I could then do. So there are a lot of benefits for integrating STK with your other tools. Definitely say that automating different procedures, going through and designing a scenario build-up, inserting your objects, computing your access, and then getting data out. It might take a little longer to write out your script the first time around, but then after you have it, you can essentially share your script out with some of your colleagues, and then all they'll have to do is hit a button to regenerate the analysis or regenerate the scenario, build up the objects, conduct the analysis, and then pull out the data. You can also push your data in, like we basically drove STK and pushed in a behavior for a LEO satellite to see it in our scenario. And then if we did want to post-process our data or just essentially extend the analysis, now that we have the data pulled into Python right now, we could certainly leverage other calculation capabilities and then post-process the data as well. I hope you guys enjoyed this lesson, and I hope it was a good exposure to you guys for using Python in a different way, using Jupyter Notebooks to integrate with STK. One of our other examples is doing this with Spider with Anaconda. This is certainly the exact same script and workflow, just a different use case. So I hope this was a good exposure to it, and I hope you join us next time for any of our upcoming virtual training classes.